Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be taking a look at how to find the discriminant of quadratic equations and how to use the discriminants to find the number of roots and also the nature of the roots of a quadratic equation. Don't forget, we have some practice problems at the end of this presentation, so we advise you to watch the entire presentation and try out the practice problems to see how well you master the contents of this tutorial. Tons of support resources can be found on mathgotserved.com. Do check it out or just take a look at the links in the description below. Alright, so to get us started, we're going to take a look at this chart that shows us how we can use the discriminants to describe the nature of the roots and also to determine the number of the roots of a quadratic equation. Alright, so what is a discriminant? The discriminant is the expression b squared minus 4ac. It's a portion of the quadratic formula. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac. And the entire thing is divided by 2a. Alright, so the discriminant is simply the radicand component of your quadratic equation. The b squared minus 4ac, that is what your discriminant is. Okay, all right, so how does the discriminant tell us the number of the roots and also the nature? So we have four cases we're going to be looking at right here. Case number one is where the discriminant is negative, which basically means that you will have to take the square root of a negative number when finding the roots. If the discriminant is negative, you have two distinct imaginary roots. Graphically, you have a situation where the parabolic function for the quadratic equation never touches the x-axis. If there's no intersection, then there are no real solutions. They're both imaginary. Case number two is where your discriminant is 0. When your discriminant is 0, you have exactly one real rational root. And that happens when the parabolic function touches the x-axis exactly once. Okay, it's as though the x-axis is tangent to your quadratic function. Case number 3 and 4 are cases where you have a positive discriminant value. When your discriminant is positive, you're going to have two real roots, okay? If it is a perfect square, you have case 3 where it's two real rational roots, because when you take the square root of a perfect square, you have a rational number, okay? And then in case number 4, b squared minus 4ac is greater than 0 and it's not a perfect square. In that case, you have two real irrational roots. In this situation, you're rooting a non-perfect square, so then in the simplified state is going to be irrational. So that is why you have two real irrational roots when your discriminant is positive and not a perfect square. Okay? All right, let's take a look at some examples. If you want to access these formulas, you can go to mathgotserved.com or scan the QR code to gain access to our collection of must-know Algebra 2 formulas. All right, so the instructions for the examples we're to do are for us to find the value of the discriminant, then use it to describe the number and nature of the roots or solutions of the quadratic equation. So don't forget, the solutions to a quadratic equation and the roots of the related graph mean exactly the same thing. All right, so for question number 1, let's say we have the quadratic equation x squared minus 4x plus 4 equals 0. All right, so before we get started, let's take a look at the steps that we can use to accomplish our objective. So here are the steps. To use the discriminant to find the number and nature of the roots, the first thing you want to do, really important, is you want to write the equation in standard form. All right. What's the standard form of a quadratic equation? Is ax squared plus bx plus c equals 0. All right, so when you write it in standard form, you can advance to step 2, which is to find a, b, and c. Find your a, b, and c values. All right, and then now that you have a, b, and c, those are the ingredients you need to find your discriminant. Okay, so you plug in, you plug a, b, and c into the formula, b squared minus 4ac, that will give you the determinant, the discriminant, sorry, and then you're gonna use the chart to describe the number of roots and the nature. Use the chart that we took a look at earlier. Okay, so let's go ahead and do it. So here, let's look at what kind of form our equation is in. So this quadratic, if you look at it, it's in descending order of degrees. So you have the quadratic term, the linear, and then a constant. So it's in standard form. Excellent. So step 1 is already taken care of. All right. So we can easily see that this is A, B, and C. All right. So A is 1. B is -4. And C is 4. All right. Step 2, we're going to plug it in. Step 3, we're going to plug into the discriminant formula. So you can write a discriminant using the delta notation. So the discriminant is b squared minus 4ac. Okay, so we're going to plug in. B squared is -4 squared minus 4 times a, 1 times 4 for c. And then now you just PEMDAS this expression. Please excuse my dear Aunt Sally. Okay, so it's just arithmetic from here on out. All right, so let's do the exponents first. -4 squared is 16. So 16 minus 4 times 1 times 4. We have minus and 2 products, so we're going to multiply left to right first before we subtract. So bring down 16, multiply these two. 4 times 1 is 4 times 4. Okay, and then multiply again before you subtract. 4 times 4 is 16. 16 minus 16 is 0. So your discriminant is 0 for question number 1. All right, so now that we found the discriminant, let's describe the nature of the roots. So since the discriminant is 0, since the discriminant is 0, we have, what do we have? So let's go back to the chart. All right, we have 4 cases, 1, 2, 3, 4. All right, so you can see that we're dealing with case 2, b squared minus 4ac equals 0. In that case, you have one real root, one real rational root. Okay, so since the discriminant is equal to 0, we have one real rational root or solution, one real rational solution. The same thing. Okay, all right, so that's that for question number 1. Okay, so let's take a look at number 2. We're just going to follow the same steps. So for question number 2, let's say we have the quadratic equation 9x squared minus 4x plus 8 equals 0. So we want to find what the discriminant is, and then use that discriminant value to describe the number, nature of roots. Okay, so take a look at the equation that we have. It's already in standard form, okay, of the form of the quadratic equation. So we can simply extract a, b, and c without doing any work. A is 9, b is -4, and c is 8. All right, so step number 3, we're going to plug these values into the formula b squared minus 4ac, the formula for the discriminant. So that's going to be -4 squared minus 4 times a, which is 9, times c, which is 8. All right, now we're going to PEMDAS this expression. -4 squared is positive 16 minus 4 times 9 times 8. All right, so let's go ahead and multiply these out before we subtract. So we have 16 minus, if you multiply 4 times 9, you get 36 times 8. All right, and then multiply again, the last two. 36 times 8 is 288. All right, and then you subtract. Discriminant is going to be 60 minus 288 is -272. All right, so in this particular case for number 2, since the discriminant negative 272 is negative, all right, so do you remember what the rule is? If for a negative discriminant value, let's scroll back up. If the discriminant is negative, is case 1, you have 2 distinct imaginary roots. Okay? Since the discriminant negative 272 is negative, there are 2 distinct imaginary solutions or roots. It doesn't matter. Solutions, or you can call it roots. Okay? All right, let's move on to question number 3 of the quadratic equation. Negative 8x squared minus 10x minus 4 equals negative 7. All right, so let's do this one. All right, so if you take a look at this particular equation that we have right here, it is clearly not in the standard form. Okay, so we're going to have to fix that. So to put in standard form, we just simply have to move this constant to the left side. Is going to be equal to 0. All the terms on the left side are already in descending order of degrees, so let's just go ahead and add 7 to both sides of the equation. We don't have to reorder anything at all here. So we add 7 to both sides of the equation. That will give us, what will that give us? That will give us the quadratic in standard form, negative 8x squared minus 10x, combine those two, plus 3 equals 0. Okay, so with this setup, we can easily see that A is negative 8, B is negative 10, and C is 3. Okay, so the next step, we're going to now figure out what the discriminant is using b squared minus 4ac. So if we plug it in, we're going to have negative 10 squared minus 4 times negative 8 times 3. So let's do the exponent first, following order of operations. Negative 10 squared is positive 100. Remember, minus times minus is plus. Okay, minus 4 times negative 8 times 3. And then we have to multiply before we subtract. So 4 times negative 8 is negative 32 times 3. All right. We can resolve these two signs, just times it together. Minus times minus, that's going to become a plus. So 100 plus 32 times 3. And then we multiply 32 by 3. You get 96. 100 plus 96. And then when you combine these two, you get 196. Okay? This is a perfect square because 196 is the same thing as 13 raised to the second power. Okay, so we have a positive discriminant that's a perfect square. All right, so what's our conclusion going to be? Since the discriminant, 196 is a positive perfect square, what does that mean? What's the nature of the roots and number of roots? Let's scroll back up. If you have a positive perfect square for a discriminant, there are 2 real rational roots. Okay, there are 2 real rational roots. So since the discriminant 196 is a positive perfect square, there are 2 real rational roots. So all right, so here are your practice problems, 4 problems for you to try out. So what we'd like you to do at this time, let's do a real quick fix to question number 3. Go ahead and pause the video presentation and try out these 4 questions. When you are done, click on the playback button and we're going to reveal what the correct answers are. All right, so let's take a look at the solutions for question number 1. The discriminant is 20. So with that, we have 2 irrational roots, 2 rational solutions. For number 2, your discriminant is equal to 1, which is a positive perfect square. So in this particular case, you have 2 real rational roots. Two real rational solutions. For question number 1 is real also. Okay. And then for number 3, our discriminant is equal to 0. So in this case, you have 1 real rational solution. And then for number 4, the discriminant is negative 15. Okay, so which is a negative number. So in this case, you have 2 distinct imaginary solutions or roots. Thanks so much for taking the time to watch this presentation. I really appreciate it. Don't forget to help support our channel with your comments, likes, and subscriptions. Tons of support resources can be found on mathgotserved.com. If you have any questions, let us know in the comment section below. Thanks again for watching. We'll see you in the next video. Goodbye.